Good morning everyone. Today we are going to start our chapter 4, structure of atom. In this we are going to start with atomic model. First model is Thomson model of an atom. See, Thomson's full name is J.J. Thomson. He given us the model of the atom, in which he compared his model with watermelon. Likewise, in watermelon, the red edible part, he compared that red edible part with proton, that is positive sphere. And likewise, in watermelon, negative seeds are embedded in the red edible part. In atom also, negative electrons are embedded in the positive sphere. That what he given us. Thomson compared his model with watermelon or Christmas pudding. Thomson said that atom is spherical in nature, and in this the whole atom is positive, in which negative electrons are embedded. He said that negative and positive charges are equal in magnitude, and atom on the whole is electrically neutral. That much positive charge is there, that much equal negative charge is there. Negative positive, equal negative and positive will cancel out, and the overall atom is neutral. After Thomson, Rutherford came. Rutherford given us gold foil experiment. He took a very thin gold foil. The gold foil was very thin. The gold foil was about 100 atoms thick. It was so thin that even though the gold foil is very thin, still it contains 1000 atoms thick. Okay. In the gold foil, he bombarded alpha particles, fast moving alpha particles. Alpha particles were doubly charged helium ions. Helium ions, atomic number 2, mass number is 4. Helium ions is having 4 mass number. Alpha particles are just helium like particles. These fast moving alpha particles, they are doubly charged. When you take out 2 electrons from helium, it forms He2 positive. Alpha particles are similar, they are doubly charged. When we strike the fast moving alpha particles on the gold foil, what he observed that most of the alpha particle pass straight. You can see in the figure, most of the alpha particle pass straight. Then after that, some alpha particles strike the atom and then gets deflected through some angle. Then after that, some very few particles strike the atom and they rebound. Okay, these 3 observation what he observed after doing his gold foil experiment. When he observed that most of the particle pass straight, from that he concluded that most of the space inside the atom is empty. Then when he saw that many alpha particles get deflected through some angles, from that he concluded that in the atom there is something called positive inside the atom, and that positive is very small because very few particles get deflected through some angles. Then after that, very few particles rebound. It's about 1 out of every 12,000 particles get rebound. Rebound means the alpha particle comes straight, it strike the atom and get deflected through 180-degree angle. So from that he concluded that the nucleus is very heavy mass and it is very concentrated. These are the observation and calculation. So features of Bohr model are: positively charged center in an atom called the nucleus. All the mass of an atom reside in the nucleus. Then electrons are revolve around the nucleus in circular path. That what he concluded. Then he said the size of nucleus is very small as compared to size of the atom. Now next, the drawback of Bohr model. The drawback of Bohr model was Rutherford model. He took the atom. He said that inside the atom is the nucleus and electrons are revolving around the nucleus. If a charged particle revolve around the nucleus, it keeps on losing its energy and shorten its path. When it shorten its path, it will follow a spiral path and it will finally fall down into the nucleus. And if this situation arises, then we can say that atom will collapse, but this do not happens. So that was the drawback of Rutherford model. Thank you.